On number 15 from section 2.5, it asks us to take this function f of x equals x to the third plus 2x squared minus x minus 2. It asks us to do the rational root test. The rational root test, remember, that's your p values divided by q values. So that's all your coefficients, sorry, all your factors of your constant divided by all the factors of your leading coefficient. Well, the p values would be all the factors of the constant, so it'd be plus or minus 1 and plus or minus 2. Our q values, thankfully, we have a fairly short list there. It'd be factors of our leading coefficient would be plus or minus 1. So our p over q's are positive and negative 1, positive and negative 2. Now, taking a look, we're given a graph. The graph looks a little something like this. This is not going to be perfect, but it looks, like so, where it goes up through x equals 1. So really, let's start with that. Let's assume x equals 1 is one of our zeros. So using that, we're going to use x equals 1, in other words, the factor x minus 1. We'll get to that in a second. And we're going to divide that out from the from the function x to the third plus 2x squared minus x minus 2. Using those coefficients, we don't have any missing terms. X to the third, x squared, x to the 0. We got that. So we're going to use our coefficients 1, 2, negative 1, and negative 2. And we're going to use synthetic division, first of all, to help us factor, but also to just kind of verify we did it right. So drop that first one. Always multiply by the number in the box. So when we multiply by 1, we get 1. Add those two together, we get 3. Multiply that by the 1 in the box, we end up with 3. Add those together, we get 2. Multiply that by the 1 in the box, we get 2. Add those together, we get 0, which is good because that verifies that it actually is a 0. So from there, x equals 1, the factor version of that is x minus 1. And now we're left with 1, 3, 2. That's 1x squared plus 3x plus 2. Now from there, we can actually factor that a little bit more. We've got x minus 1. X squared plus 3x plus 2 can factor out to x plus 1 times x plus 2. Thinking about a different problem, sorry. So that gives us 3 different zeros. We have x equals 1, x equals negative 1, and x equals negative 2. And you can also see that on the graph as well, it matches up with all 3 of those.